Good morning, everyone. I'm Lemuel Jose Anthony D. Francisco. I'm a first year mechanical engineering student from Central Philippine University. Today, I'm going to teach you integral calculus. The two topics of integral calculus, which are the area and the volume. In the area, we're, we're going to solve under the curve the area between the curves and the polar area. In the volume, we're going to solve the disk method, shell method, and washer method. The learning objectives for area is use in definite integrals to find the area between a curve and a non-horizontal or vertical line. Use definite integrals to find the area between the curve of two given functions. Y equals f of x and y g of x. Use definite integrals to find the area of a region bounded by more than two curves and with or lines. The principles of area is definite integrals can be used to find the area under a curve. They can also be used to find the area between two curves. To find the area between two curves defined by functions, integrate the difference of the functions. If the graph of the function cross or the region is complex, use the absolute value of the difference of the functions. In this case, it may be necessary to evaluate two or more integrals and add the result to find the area of the region. The area under a curve. This will be our first topic. The area under a curve between two points is found out by doing a definite integral between the two points. To find the area under the curve, y f of x between x equals a and x equals b, integrate y equals f of x between the limits a and b. This area can be calculated using integration with given limits. So the formula under a curve, the area under a curve between two points is found out by doing a definite integral between the two points. To find the area under the curve, y equals f of x between x equals a and x equals b, integrate y equals f of x between the limits of a and b. area between the curve. To find the area between two curves defined by function, integrate the difference of the function. If the graph of the function cross, or if the region is complex, use the absolute value of difference of the functions. Formula. The formula of the area between two curves is calculated by the formula area equals the area equal to the integral of f of x minus gx with a limit of a and b dx, which is an absolute value of the area. This is my example. So next, polar areas. To To find the area between two curves in the polar coordinate system, first find the point of intersection. Then subtract the corresponding areas. The formula of a polar area inside the area inside of a polar curve r equals to f theta. We start with the area of a slice of pie. If the slice has angle theta and radius r, then it is a fraction theta theta 2 pi of the entire pie. So its area is theta pi times 2 pi pi r squared equals to r squared 2 pi. So this is my example. Value of solid revolution. Learning objectives. Students will recognize volume as attribute of solid figures and calculate the volume of simple rectangular prism by counting cubic units. Principle, Principles of volume. A solid of revolution is the three-dimensional object. Number 2, obtained by rotating a function in the plane about a line in the plane. The value of this solid may be calculated by means of integration. Common methods for finding the volume are this method, the shell method, and Pappus's-Centroid theorem. This method. This method is the process of finding the volume of an object by dividing that object into a small cylinder disk and then adding the volume of these small disks together. The formula is for this method will be the region bounded by y equals f of x, y equals to f of x equals to a of x equals to a, x equals b of x equals to b, and y equals to suppose we form a solid by revolution around the x-axis. Example. The shell method is a method of finding volumes by decomposing a solid of revolution into cylindrical shells. Consider a region in the plane that is divided into thin vertical strips. It is vertical if each vertical strip is revolved about the x-axis, then the vertical strip generates a disk, as we showed in the disk method. So the formula, a similar process with a cylindrical shell, with height and thickness and approximately radius. Cutting the shell and laying it flat forms a solid with length 2 pi r, height h, and a depth dx. Thus the volume is the volume is equals to 2 pi rh dx, or volume equals the integral of dv equals the integral the integral of 2 pi xy dx and the limit of a and b. this is my example for shell method. Washer method. A method a method of computing the volume of a solid of revolution that is hollow about its axis by integrating other the volumes of infinitesimal washer-shaped slices bonded by planes perpendicular to the axis of revolution. The formula: the outer cylinder has radius of r of y and the volume of the outer cylinder has radius ry. Its volume is equals to r ry times pi times v. In other words, the volume is equals to the limits, the integral of pi times v squared minus y squared dx with the limits of a to b. This is my example. Thank you for watching.